Hi all, welcome to Healthy Living with Dr. EE. Before we begin the event, please be reminded that the content is copyrighted. No recording or sharing is allowed. Let us all welcome our special guest for today, Dr. EE Zhang.
Hi, everyone, and thank you so much for taking the time out of your Saturday morning to listen to my talk. I'm so grateful to have this opportunity to share all this knowledge with you.
Dr. EE, cancer is one of those diseases that hovers at the back of everyone's mind. Can you tell us more about how it happens and give us some tips on how to avoid it?
All right, so first I want you to take a look at this graph. Now, if you take a look at this graph, you'll see that the number one killer in the world is actually heart disease. But the thing is that when people go to the doctor's office, it's never heart disease that's hovering at the back of their minds. It's always something like cancer, something scary like cancer. Even if it's for a simple problem, it's always at the back of your mind going, what if? What if it's cancer? And then the next thought is always, you know what? It's not going to happen, at least not to me. But if you look at this graph, cancer is actually the number two killer in the world. So if you're not going to die of heart disease, then you're probably going to die of cancer. So it's not as far-fetched as people might think. Now, unlike other terrifying diseases on the list, cancer is actually pretty common. It's the second leading cause of death in the world after heart disease. So in 2018, there was an estimated 9.6 million deaths worldwide due to cancer. On a global scale, 1 in every 6 deaths is due to cancer. So cancer occurs in people of all ages, and it's also one of the leading causes of death for children as well. So it's not just old people. Every year, there are about 300,000 new cases diagnosed in children aged 0 to 19 years. And about 38.4% of people will be diagnosed with cancer in their lifetimes. So have a look at this chart. Now, out of all of the cancer deaths in the world, number one is the lung, or the respiratory tract, then the colon, and then the stomach, liver, and breast. Now, colon cancer is one of the things that we do have to be worried about as well, especially in Asia. Colon cancer is more common in Asia compared to Western countries. So it's one of the things that us living in Asia, we have to be particularly vigilant about. Now, if you look at this chart, you'll see that cancer affects people of all ages. Now, most people, they think that cancer is something that only happens to older people, or they think, because I'm young, it's not going to happen to me. It might happen, decades from now, but not now. Right? So I'd like you to have a look at this. Cancer does happen in people who are young. It's almost, 20% if you look at this chart but please note that this chart is talking about cancer deaths and not the diagnosis. So it doesn't show you all the people who have been newly diagnosed or people who are living with cancer or people who have recovered from cancer. It's just talking about cancer deaths. So the chart might be a little bit misleading because, as you know, cancer takes a bit of time to grow. So by the time someone dies from cancer, that might be a few years from when their cancer was first diagnosed. And let's have a closer look at this idea. Now, cancer is a slow progressive disease. Usually we think of it as something that happens quite fast because of the experience where we hear someone has cancer and then they will die quite quickly. But as with many other health conditions, cancer takes time to develop. It does not appear overnight, and it doesn't grow as fast as you might think, not as fast as bacteria. So for example, whereas you might notice an infection taking hold in a few hours or a few days, it might be years or even decades before you notice a tumor. Like bacteria, cancer cells will double in number over time. But while the doubling time can be mere minutes for bacteria, for cancer cells, it can be days. For example, lung cancer may be developing and growing in your body for 10 to 20 years before it's detected. So all that time, it's just biding its time, sapping your nutrients, your strength, until you finally notice it there. So cancer is a slow progressive disease. In fact, the term early stage cancer is a little bit misleading, as the patient might think that the cancer has only just happened, that they only just had cancer cells appear in their body. That's not true. Some cancers can be fast growing, but others can be slower. For example, for lung cancers, a rapidly growing one can have a doubling time of less than 183 days, while a slower growing one can have a doubling time of 365 days. With a doubling time, let's say in the middle somewhere, about 200 days, cancer would take about 20 years to grow to a detectable size. If it has an even faster doubling time of maybe 100 days, then it'll take about 10 years. For example, for lung cancer to be detectable with modern technology, it's probably been growing slowly for nearly 10 to 20 years. Therefore, if we detect lung cancer at the age of 40, the cancer cells have probably already been present in the body since the 20s. Breast cancer might grow for 6 to 8 years, colon cancer might grow for 20 years before it's detected. So for about 2/3 of the history of a cancer, neither you nor the doctor will know it exists. There might not even be any symptoms at all until it's been growing for years and years and years and it's reached the size where it's actually pressing on things and causing problems. So people might think, you know what, we have modern technology. Can't we find this? What if I go for a scan every year? Is that going to help me? Well, we have this idea that our medical system, our medical technology is something out of Star Trek. You know, you wave that device over someone, send them through a scanner, ask the machines, and the machines will tell you what's wrong with you. That's not necessarily true. The scanners don't reveal all. And then sometimes, you know, the scanners, they might miss something too. With x-rays and CT scans, we can see inside our bodies and find tumors, but only tumors of a certain size. The limit for x-rays is about 4 to 6 millimeters. A tumor will usually divide about 30 times to reach about that size. All right, so for x-rays, it's about 10 to 20 millimeters. For CT scans, it's about 4 to 6 millimeters. So an x-ray is a little bit bigger because an x-ray is not as detailed as a CT scan. But even with our CT scans, it will still have to grow about 30 times before we'll be able to find it. So that's a lot of cells. In order to reach that size, that's about 10 billion to 100 billion cancer cells already residing in your body by the time that we even know it's there. So that's a lot of cells. And don't forget, the more time passes, the faster cancer will grow because the faster it can double in size. But actually, you know, when you think about it, it's not actually easy to get cancer. Cancer is a frightening disease. People think that because they're exposed to something like a certain chemical or a carcinogen or a source of pollution, then it'll have an immediate effect on their bodies and they will get cancer. But that's not the case. Cancer is something that has to grow and develop over time. So this is also another thing that trips people up sometimes. They think, you know what, I came into contact with this thing that's supposedly harmful, but nothing's happened to me. So, you know what, I guess it's not as dangerous as people think. Well, when in reality, the thing is that these effects can take years to develop. So even after you come into contact with something harmful, it could be years before you see the harmful effects. So that gap in that time period can trip a lot of people up as well. So it doesn't happen immediately. Cancer is something that takes time. And it's also something where a lot of things have to go wrong all at once. All right, so cancer is not like a flu. You know, you have to have mutations in order to get cancer. So cancer is what happens when your normal body cells become abnormal. And they become abnormal because their DNA is mutated, because there's something going wrong with the cells there. So you can't just magically get a cancer cell. One of your normal, previously healthy cells has turned cancerous. Right? So cancer is caused by mutations, but not a single mutation. There's usually a lot of things that have to go wrong before you get cancer. It's like the Swiss cheese model. You know, when you have slices of Swiss cheese, it's got holes in it, right? But if you take a ball and drop it through one of the holes, it can only drop through all the way if all of the holes are lined up exactly. You know, when you stack Swiss cheese normally, you might have a hole here, but then underneath there's no hole. So if you drop the ball through, it's going to be stopped, right? It's the same thing here. A lot of things have to line up in order for cancer to happen. So a lot of things have to go wrong before you get cancer. So really, cancer is not something that's easy to get. So that's reassuring. Research published in Genes and Cancer has shown that there are over 1,000 mutations in lung cancer. The American Journal of Pathology has research published estimating that the total number of mutations in cancer is more than 10,000. Research published at the Proceedings of the National Academy of Sciences of the United States of America says that the typical colorectal cancer contains at least 11,000 mutations. So most people know that cancer runs in the family. For example, if someone's mother had breast cancer, their risk of developing breast cancer is higher. Now, cancer does have a genetic link, but that's not the most important factor. You know, there's also other things as well. So if you have a family history of cancer, don't think that it's unavoidable or inevitable that you will also get cancer. That's not true. There's also other things as well. For example, people in families, they tend to live in the same area. They tend to have the same diets. They tend to be exposed to the same things in the environment. So there is that as well. So, but it doesn't mean that if you have a genetic predisposition to cancer, it doesn't mean that you will automatically get cancer. It just means that you have a lower threshold for those cells become cancers. For example, someone without a genetic predisposition might say, you know, maybe need 1,000 mutations. I'm just pulling numbers out, 1,000 mutations. Whereas if you have a genetic predisposition, you might need 900 mutations. All right, so it doesn't mean that you will get cancer. Only about 5 to 10% of cancers do inherited genetics play a major role. The rest of cancers occur because of things that happen in our life, because of our lifestyle. All right, so cancer is usually caused by these mutations, and there's a lot of factors which can cause mutations in your otherwise healthy cells. For example, some bacteria and viruses can cause mutations. Carcinogens will cause mutations. Tobacco smoke can cause mutations. That's why smokers get lung cancer. Right? Burned foods is actually not very good for you. That's why people always say you can't eat burned foods, not just because they don't taste very good, because they're also not good for you. There's also things like exhaust gas from engines or other chemicals that you might see or might come into contact to in the environment, etc. And there's also other things as well. For example, even shift work can cause damage to your DNA because you don't have a normal sleep pattern. So a cancer cell will need thousands of mutations. And even if these cells mutate, we also have a backup plan. We have mechanisms of fixing it. Our immune system is designed to patrol our body and look out for those foreign invaders, those bacteria and those viruses, and get rid of them. But what our immune system also does is that it also monitors our body's own cells. So if our own cells, they turn a little bit weird, they turn a little bit cancerous, they got mutations there, your immune cells will go, you know what, that cell does not look right. And then it will launch an attack and destroy your abnormal cells. So our immune system has this function as well. So it's protecting us from threats outside and within our body. So we do have a backup plan in case we can't stop these mutations. Because if you think about it, you know, it's not realistic to avoid everything in the world that could cause damage to our cells' DNA. For example, exhaust gas from cars is a carcinogen, but we live in a city and we can't avoid it if we want to breathe, right? So we have to support this backup plan of ours. We have to support our immune system in its goal to protect our body from these threats, from the outside our body, and also from the threats from our body's own cells. However, cancer cells, they also work at hiding from the immune system. So it's a little bit like a cat and mouse game. For most cancer patients, the cancer cells have been quietly growing for years without causing any symptoms. So in the early stages, if you're healthy, if you have a healthy lifestyle, you have a healthy diet, your body is healthy, your immune system is strong, what happens then is your immune system gets rid of these cancer cells before you ever know that you've ever had them. However, if the body is unhealthy, if these mutations keep happening and your immune system can't get rid of these cancer cells, then what happens is that these cancer cells will grow and they grow and they grow, and then eventually they start causing problems. So the question here is your immune system healthy and strong enough to identify these problematic cells and get rid of them for you? If the answer is no, that's when cancer has a chance to develop into something that doctors can find. And at that point, another player is added to the game, the doctor and their medications. So the thing about cancer cells is that they're really, really abnormal cells. Cancer happens when normal cells of the body go out of control. Normally, our body cells has very strict rules to play. For example, your lung cells, they help you exchange oxygen for carbon dioxide. They help oxygenate your body. That's their goal. Your skin cells play the role of skin. They do their job well and they don't interfere with the functions of other cells. Cancer cells don't do that. Cancer cells are mutated cells that cause a lot of harm. Number one, they don't do the job they're supposed to do anymore. So if you have a lung cancer inside your lung, none of those cells are helping your body oxygenate your blood. They're just not helping your body at all. They interfere with the function of the other cells around it. So not only are they a leech on your body, they're also dragging all the other cells down with it. They eat up all the nutrients, so the surrounding cells die off. They don't stop growing. Normal cells know when to stop growing. Cancer cells do not. And 5, they spread to other areas of the body. And even worse, these cancer cells are essentially immortal. Normal cells have what is called a telomere on their chromosomes, the genetic material, which determines a cell's normal lifespan. When these normal cells replicate, their telomere becomes shorter until eventually the cells reach the end of their natural lifespan. At the end, or if they're damaged or mutated, whichever comes sooner, the cells will undergo, programmed death called apoptosis. Now, cancer cells, they don't do that. They just don't die. Now, take, for example, if you grow normal cells in a lab, they usually deteriorate after about 2 doublings. But cancer cells will continue to double or replicate indefinitely. In fact, the HeLa cell line, which is one of the most common human cell lines used in research, actually came from cancer cells in the 1950s and is still used today. All right, so these cancer cells, they have this ability to repair this telomere so that it just won't die and it keeps continuing to replicate, keeps continuing to eat up resources and cause harm. Another thing cancers do is that they spread or they metastasize. We have what are called adhesion molecules, which is basically telling your cells to stay where they are. So for example, your lung cells stay in your lungs. You don't get lung cells on your skin or in your colon, right? That's just something out of a horror movie. So your cells stay where they are normally. But for cancer cells, they don't do that. Cancer cells, they will detach from their previous home and then just spread throughout their body wherever they can. All right, cancer cells ignore this signal from the body to stay where they are. All right, and because they don't function properly, wherever they go, they're not helping your body out. They're only draining resources and causing harm to all of the other cells around it. Another thing about cancer cells is that they also ignore the boundary signaling of cells. Normally, as your cells grow, the other cells surrounding them will be like, you know what, this is the limit of your growth. You have to stop here. It's like if you're in a crowd, and you're pushing against someone, that someone's going to tell you, you know what, you got to stop pushing. This is as far as you can go. This is the limits of where we can go. And so you stop and you stay where you are. Cancer cells don't do that. Even if the other cells are telling the cancer cell, you gotta stop, you can't go any further, the cancer cell will just shove it out of the way or trample it or basically kill it to get where it needs to go. That's why cancer can eat through organs. That's why cancer tumors can spread, past an organ into the surrounding areas because they ignore this boundary signaling. All right, so that's another thing that differentiates cancer cells from normal cells. Cancer cells will also keep mutating. Now, cancer cells are not stable cells. As they replicate, they change and they mutate further. If you ever look at cancer cells underneath a microscope and compare it to normal cells, they look really abnormal. They do not look like normal cells. All right, so they are really abnormal cells that continue to mutate and continue to become more and more abnormal. Now, because of this, they can become resistant to certain types of therapies used to treat cancer. For example, if you have breast cancer, it could start off as ER positive. So doctors will tailor their treatment for this particular receptor that they found on their cancer cells. But then later on, your cancer cells might mutate and these receptors change and it becomes ER negative, which means that the previous treatment that you were using to treat your cancer is no longer as effective. All right, and what's more is that cancer cells in the same tumor can be different. This means that while your treatment might work really well against some of the cancer cells, it might not work that well against other cancer cells. And as we all know, you only need one cancer cell for the cancer to come back and to keep growing. All right, so when it comes to cancer, cancer is always something that's really, really scary. So let me give you some tips on how we can help prevent cancer. When it comes to cancer, prevention is the key. All right, we don't want to wait until we can detect it. We don't want to wait until doctors can find a cancer before we start doing something there. No, we want to nip it in the bud. We want to support our body in this goal to get rid of the cancer cells before we even know it's there. So let's have a look at all of these easy things that everyone can do. There's a lot of things that we can do in our day-to-day life to help reduce our risk of cancer. And all of these things are just really easy things. All right, it's nothing complicated. It's nothing out of the reach for most people on Earth. All right, so number one is don't eat moldy foods. I feel like this should be obvious, but I should explain it a bit more. When it comes to moldy foods, it's not the mold we're concerned about necessarily, but the toxins it produces. For example, let's take bacterial toxins. For example, Botox, commonly used for cosmetic procedures, is a bacterial toxin. Now, if we take just 1 gram of this toxin, it's enough to kill more than 1 million people. So it's super toxic. So aflatoxins are what we're worried about. Aflatoxins come from a type of mold that tends to grow in crops. For example, in improperly stored peanuts, corns, grains, or even soybeans, especially in these humid, warm environments. Now, this is a significant contributor to cancer worldwide each year. It's estimated about 25,000 to 155,000 cancer cases might be attributable to aflatoxin exposure. So for some people, especially the more frugal people, they might see mold on, for example, their soybeans, and they might just wash it off. Or they see mold on a bit of their food, and they just cut off the bit with the mold and eat the rest. Or they think it's going to be fine, it's going to be cooked anyways, and the cooking will kill the mold, right? Well, yeah, cooking might kill the mold, but it doesn't get rid of the toxins that the mold has produced. The toxins will remain, and the toxins are what we are concerned about. So, and if you just think about it as well, when it comes to mold, the visible part of the mold is a tiny part of the mold. It's like the tip of the iceberg. The main body of the mold is inside the food where you can't see it. It's already throughout your food. So if you see mold on your food, just assume that the entire thing has been contaminated by mold. You just can't see it. It's just inside your food, all these tendrils going inside your food. So it's already there, all right? So if you see mold there, the best choice is to just don't eat it. All right, and the thing is that some kinds of toxins can penetrate the skin as well, and not all mold or toxins can be completely washed or cooked away. For example, coffee beans are roasted at about 180 degrees Celsius, but if there's mold on the coffee beans, about 50% of it will still be there after roasting. And if you just think of our home cooks out there, how many of you will use 180 degrees Celsius to cook your food, right? Most of us were just pan frying food. So if our food has gone bad, if it's got mold on it, then the best thing is that just avoid it entirely. All right, just don't take the risk and just don't eat it. If you flush right after drinking, don't drink. All right, so if you've seen those people, right? They take just a sip of alcohol and then they flush bright red, as red as a tomato. So it's got, a lot of people might think it has something to do with the health of their liver, whether their liver is super healthy or super unhealthy. But in reality, it's got very little to do with their liver. It's actually a genetic thing. They're lacking the enzyme aldehyde dehydrogenase 2, which means that people who flush red after drinking, they can't break down alcohol very efficiently. This means that these toxic components of alcohol stay in their body longer, irritates the blood vessels, and that's why the blood vessels will dilate and cause the flushing. All right, so roughly 1 in 3 of all Asians will have this deficiency. So people who go red, they should not drink alcohol. They have an 18 times higher risk of getting esophageal cancer. And they're also more prone to getting liver cancer or gallbladder cancer too. So esophageal cancer has a 5-year survival rate of 18%, liver cancer about 17%. So those are bad cancers to get. So a lot of people might think, okay, you know what if I cook it instead? What if I use wine for cooking? Is that okay? Even if you boil your alcohol or wine, it doesn't cook away. As much as 85% of the alcohol might still remain. So the best, healthiest course for people like this is to avoid drinking alcohol and to avoid eating foods that have alcohol as well. Next up is eat more fiber. Now, fiber has protective effects against cancer, against colon cancer, breast cancer, ovarian cancer, and endometrial cancer. Now, out of all of the plant foods out there, psyllium has one of the highest fiber contents. So the recommended daily intake of fiber is about 30 grams a day, but for most people, we only get about 15 grams. So for a lot of us, this is an area of improvement. And it's also something that it's really easy to do. All we have to do is eat more plant foods, eat more vegetables, eat more fruits. And that's something that we should be doing anyway. Next up is we have to be picky about our cooking oil. Now, a lot of people, they might be picky about the foods they eat. They only want the best foods. They only want the healthiest foods. But then when it comes to actually cooking these foods, they're not so picky about their cooking oil. If you think about it, your cooking oil comes into contact with most of the foods that you end up eating. So we do actually have to be picky about cooking oil. What's the point of being picky about the foods we eat if we then just coat it all in this unhealthy oil, right? So we want to use cooking oils with a high smoke point, no lower than 200 degrees Celsius. When we're looking at these oils, the smoke point is really important. Now, when I'm talking about the smoke point, I'm talking about the temperature at which oil starts to smoke. As soon as it starts to smoke, it's starting to produce carcinogens. All right, so it's something that's not very good for us. It will start producing carcinogens like malondialdehyde. For example, scientists have looked at blood malondialdehyde levels in lung cancer patients and found that there was a correlation between these levels in those with lung cancer. All right, so we want a high smoke point, especially for us in this Asian cooking. It's always a wok on flames going everywhere, right? So we use high temperatures for our cooking. If that's the case, then we want to use our oils that have high smoke points. Another thing is that we don't want to reuse our cooking oils, and we don't want to use the same cooking oil for a long period of time because this will degrade the oil and lower the smoke point. Next up is we want to eat less red meat. Now, Animal foods, they tend to be higher in fat and cholesterol. They also contain other compounds that can be detrimental to our health. For example, red meat and dairy products can contain something called N-glycolinuramic acid. The presence of this comes exclusively from our diet because our body can't synthesize it on its own. All right, so it's not something that our body produces naturally. It's been found concentrated within tumors and is thought to contribute to body-wide chronic inflammation, which in turn can increase our risk of diseases, including cancer. Now, chronic inflammation is something that's not very good for us because the more chronic inflammation we have, the more damage to our cells. And the more damage to our cells, then the higher our risk of getting diseases such as cancer. All right, so eating red meat may increase the risk of stomach cancer, breast cancer, and bowel cancer. Next up is that we also want to maintain a healthy weight. There's a strong link between obesity and cancer. It's estimated that 1 in 5 cancer deaths is caused by obesity. Obesity increases the risk, especially of hormone-related cancers, such as endometrial cancer, ovarian cancer, and breast cancer. But it also increases the risk of esophageal cancer, stomach cancer, liver cancer, and pancreatic cancer. All right, so it's something that we can control as well. It's something that is within our control. Now, there's a lot of ways that excess fat can increase risk. Having too much fat can cause more inflammation in our body, which is damaging to all of the cells around it. It can damage DNA and lead to these mutations that can cause cancer. Fat is also linked to more hormones such as estrogen in the body, which can increase the risk of these hormone-related cancers. Now, obesity can also affect our cancer prognosis. It's associated with an increase in mortality and in reoccurrence. So there's even evidence that suggests weight gain after a cancer diagnosis can increase the risk of reoccurrence. So it's really important to maintain a healthy weight. All right, so it's possible to live to 120. This is what we're doing here in nutritional immunology. We're looking at this relationship between nutrition and the immune system because we realize today, if we want to live longer and healthier, we have to have a strong immune system. When it comes to keeping our body and our immune system healthy, it's all about our lifestyle and our dietary habits. Eat healthy. Exercise more, but also remember that you have to get adequate rest as well. Stay positive, stay cheerful. People can live to 120 years, but in the modern world, we think that 80 and 90 years is already really, really good. And all this time, it's also about staying healthy as well. So it's not just living longer. We want to live longer and also be healthier as well. So we have that quality of life to enjoy for years and years to come.
Dr. EE, DNA testing kits are becoming really popular. First, it started with Ancestry, but now you can even get personalized diet plans. But do those diet plans actually work?
So if you look at these predictive DNA tests, well, you know what? Let's be a little bit honest here. We're all a little obsessed with ourselves. With the arrival of these easily affordable genetic testing kits, people thought it might be fun to find out, where their ancestors are from. But now people are using this to sort of determine the risk of certain diseases or even determine what their diet should be. But are these things actually useful? Do they actually help? So let's look firstly at these predictive genetic testings for cancer. Now, a lot of people know that cancer tends to run in the family. So people have this idea of the risks of cancer being written into your genes. They might have this view of cancer being unavoidable or inevitable, especially if they know that they have a genetic risk for cancer. Now, cancer does have a genetic link, but is not the most important factor. The more important factors at play are things like your diet and your lifestyle. All right, so only about 5 to 10% of cancers are caused directly by inherited genetic defects. Okay, and the next thing is that cancer tends to run in families because as as we all know, when you're living together with your family, you're living in the same place, you're exposed to the same carcinogens, you tend to have a similar diet as well, you tend to have a similar lifestyle. So it's all sorts of factors that tend to be the same among a family of people. So it's not just genetic risk. Now, will someone who inherits a cancer susceptibility gene definitely get cancer? No, okay, that's not the case. Okay, there's two things that we want to look at. Just because you get the gene doesn't mean that the gene will play a significant role in your life. There's two things to keep in mind: penetrance and expressivity. Penetrance is talking about how often a gene actually leads to something. So incomplete or reduced penetrance means that not everyone who has a gene will develop the disease. You can think of it as like an on-off switch for genes, okay? So it's either on and it's relevant, or it's off and it doesn't have an impact on your life. Expressivity is the extent to which a gene is expressed or shown. Let's take an easy example, all right? Let's take a look at dog breeds. Dogs of a certain breed can share the same genes, but the difference is how it's expressed. For example, if you have dogs and they all have the gene for brown fur, all right, you might have one dog with really dark brown fur, another dog with spots of brown fur, and then a third dog with light brown fur. All right, they all have the same gene for brown fur. The difference is how that gene is expressed. All right, so these two things we have to keep in mind. Just because you have a gene doesn't mean that you will get the disease, and it doesn't mean that your body will express it in the same way. So you can think of it like the on-off switch. There's something that needs to turn on a gene, and oftentimes these triggers to turn that switch on, it can be things that come from your environment. All right, so just take a look at other diseases. For example, autoimmune diseases. Autoimmune diseases can actually happen in adulthood, not always in childhood. For example, multiple sclerosis is an autoimmune disease that commonly happens in adulthood. And these diseases, they often have some sort of trigger, like a viral infection or an injury or some other stress to the body that sort of triggers this disease to happen. Now, people might think it's okay to get sick because doctors, well, we have all sorts of ways of fixing you now, but that's not necessarily the best path to rely on the doctors to fix you after the fact, because there's a lot of things that can trigger further diseases in your body, and these things can be things like medications as well. So as always, the best course of action is to try to avoid getting sick to begin with. We want to prevent getting sick. So it's important to nourish our body, nourish our immune system, and just prevent it from ever happening to begin with. Now, does this test cover all genetic variants? No, only a few genetic variants are tested. For example, there are some companies out there now that will say that they can test for variations of a breast cancer gene. All right, so it might say, oh, you know what, we will test for these genes. So if you get a report that says everything is negative, then you feel really relieved, right? You feel, oh my gosh, does this mean that my risk of breast cancer is normal, is like 0? But that doesn't necessarily mean that everything is okay. It just means that the genes they tested for were negative, and they don't test for everything. All right, so it's only saying the ones we tested for were negative, but the ones they didn't test for, they could be positive and you would never know. So if you decide to get your DNA tested for medical reasons, then you should be working together with the doctor to see what sort of genetic testing is best and for a more complete understanding of what the results will show. Clinical genetic tests will go into much more detail. For example, the commercial tests are a bit like reading a few letters in every chapter of a book, whereas a clinical test will read every single letter, often thousands of times, and will even check to see if you have chapters missing or chapters duplicated. Right? So genetic testing still has its place in the medical field. For example, genetic testing for Huntington's disease is done because if someone has a gene, they will develop the disease. Other tests, such as genetic testing for breast cancer, can also be done, but the results aren't as clear-cut, and you should be discussing it together with a doctor. Now, if you look at these, genetic testing tests, who should consider these genetic testing tests. Now, you should consider them for cancer that is diagnosed at a young age or as an infant. All right, so for people who have cancer diagnosed at a very, very young age, for oftentimes a lot of these inherited cancer types are something that happens at a very young age because it's genetic, so it's written into their genes. So if they do have it at a young age, they can get tested to see if it's genetic. And if it is genetic, then you might have a head start on their relatives, for example, any of their siblings. If they have several different types of cancer occurring in the same person, then you might see, oh, you know what, they might have a mutation there, because there are some types of genetic mutations that will increase your risks of getting cancers. But oftentimes, these people might have several different types of cancer occurring at the same time. Or if you have several first-degree relatives that come down with the same type of cancer, then again, you might go for these genetic testings. But it is something that should be discussed with a medical professional. All right, so if you have a positive result on these cancer tests, especially if you're having one of those commercial testings, then you have to take it with a grain of salt. Okay, you can't let it cause you all sorts of anxiety. It's all about probability. All right, so the reports that these companies turn out can be super misleading and might be scary to see in a report that you have an increased risk of cancer. However, what the report doesn't tell you is that the risk of cancer is normally something like 0.01%. So if you have an increase of 10 times, then that might make it 0.1%, which is still a tiny chance. These tests can also show false positives, especially for the rarer genetic variants. For example, if a genetic variant was only found in 1 in a million people, then just crunching the numbers is more likely that a positive result that you get is an error than an actual positive result. All right, so an independent clinical lab has actually looked into a lot of these results from these commercial genetic tests, and they found that about 40% of them were actually false positives. All right, so just don't let this thing give you unnecessary anxiety. Okay, it's just not worth it for your mental health. The next thing is also a negative result can also be harmful in a different way. All right, like I mentioned before, these commercial tests, they only test for a few variants. They don't test for them all. All right, so it's a bit like saying, you know what, on this 100-meter stretch of road, I can guarantee you that you will not get into a car accident. All right, but that's only for that 100-meter stretch of road. All right, they're not telling you that at the 200-meter mark, there's a sinkhole that you don't know about, okay? So it's only about these certain variants they can say is negative, and it might give people this sort of sense of false assurance. They might think that, oh, I won't have this risk, so they might not take preventative measures that they might have otherwise taken. For example, they might be less vigilant about getting health checks, such as mammograms if they're looking for breast cancer, and miss a real cancer that has developed. All right, so a negative result doesn't mean zero risk, and a positive result doesn't necessarily mean that you will end up getting cancer. All right, so can you change your genes by eating and living well? I wish. Unfortunately, we can't change our genes. What we have is what we're stuck with. There's a lot of promising research out there about gene editing, especially for specific diseases like cystic fibrosis, but that's still very new stuff and it's very groundbreaking. So far, we still don't have the technology to be able to change our genes on that widespread level. All right, so if you think about it, for these cancer mutations, a lot of the times it's multiple different mutations working together to increase your risks of cancer. All right, but for other diseases like cystic fibrosis, it's a mutation on a single gene. One thing they can fix. They can work on fixing, and even then, it's still something that they're working on. So we're not there yet. Maybe in the future we can, but we're not there yet, so it's not possible for us currently. However, remember when I said that genes have like an on-off switch? we can try to control other risk factors. For example, our lifestyle and our diet. We can try to protect ourselves against cancer by stopping these cancers from mutating in the first place, which means, number one, we have to try to avoid carcinogens. There's a lot of carcinogens that are present with a poor lifestyle. For example, tobacco smoke is one. A poor diet is one. Aflatoxin, like I mentioned before, charred foods. So about all of this, it's all about trying to avoid these risks, but some risks we can't avoid, all right? And for those risks that we can't avoid, what we can do is try to equip our body's own cells to defend against cancer cells. So as much as we try to avoid every single carcinogen in the world, it's not possible. So we want to take care of our body. We want to take care of our immune system, because our immune system is our defense system. If our immune system is healthy and strong, it can find and eliminate cancer cells before they grow into a problem. A healthy diet to support our immune system also helps protect us against cancer. Plant nutrients contain wonderful nutrients called phytochemicals and polysaccharides. Right? And polysaccharides, all of these phytochemicals and polysaccharides, they help protect our bodies in different ways. For example, phytochemicals can help stop some of the many processes that may lead to cancer. Polysaccharides can help our immune system. It can help our immune cells work in its way of trying to defeat foreign invaders and trying to defeat our mutated cells as well. And these plant foods, they also contain strong antioxidants that can help protect our cells against DNA damage. So all of these things, it sort of works together. All of these plant foods, it works together by helping reduce our risk of cancer and also helping keep our immune system healthy. Now, eating healthy means consuming less carcinogens and consuming more plant foods to help support our immune system. We don't have control over our genes, but we do have control over this. All right, and by eating healthy, we also have a greater population of healthy, normal cells as well. All right, so it's a many-pronged approach. Just by eating healthy, we are tackling so many risk factors and so many problems all in one, and it is something that we can all do. But in an effort to try to eat healthy, a lot of people will turn to DNA-based diets. Will you succeed or fail in your new diet? Will exercise be more important than your food choices? If you want to lose weight, a lot of people will turn to their genes for the answers to their dieting questions. Now, this is not anything new. People have been doing this for years. It's just in the past, DNA tests were super expensive. So they did other things instead, like your blood type or your star sign. But now that we can test our DNA by mail, a lot of people are turning to that instead. But do our genes determine our response to diet? Not necessarily. The research into DNA and its links to different aspects of our lifestyle is actually still quite new. Yes, there have been major breakthroughs, but in a really weird way, DNA and its link for things like dieting is actually super complex. There's a lot of things that we still don't know about. Now, it's obvious that not everyone will respond to the same diet in the exact same way. After all, we're not the exact same people. All right, so a lot of people will think, you know what, instead of trying the hard way of just trying out a diet and eating healthy, they just want a cheat sheet. They want something to tell them exactly what to do. But even then, it doesn't really work. All right, if you look at the PREDICT study, researchers, they looked at 700 identical twins and 400 non-twins. They evaluated, among other things, the rise and fall of blood sugar and blood fats after eating various kinds of foods. And they found that, different people respond very differently to the same dietary inputs. So there's no one dietary approach that's going to work the best for everyone. Now, if you look at this, if these differences were genetically driven or, due to your genes, then we would expect the identical twins to respond in the same way, but they didn't. Genetics appear to account for less than a third of the subject's insulin and triglyceride responses, or the blood fat responses. The specific ratio of fats and carbohydrates in the diet were also not strongly predictive. Other factors like their sleep habits, exercise, stress, or even their gut microbiome appear to play a much bigger role in their individual responses to the diet. So that's bad news for the company that sells these tests, but really good news for the rest of us because it means that it's not written in our genes and we can change it in our control. We can control what we eat. We can control how much we exercise, how much we sleep, how we manage stress, even our gut microbiomes. All of these things is within our control. We can influence these things to help reduce our risk and to help make it easier to manage our weight. All right, so DNA testing is not a good guide for weight loss. All right, research published in JAMA by researchers from Stanford University Medical School investigated over 609 overweight adults over 12 months. They split them into two groups, a low-fat diet and a low-carbohydrate diet. They looked at their genes involved in fat and carbohydrate metabolism. So they looked at these diets and then they sort of compared it to what genes these people had. And they found that there was no difference in weight loss between the two groups. It didn't seem to matter what genes they have or their genotype. It just didn't account for their weight loss when they tried either a low carb or a low fat diet. The results actually showed a wide variation in blood responses to the same meals, whether or not they contained carbohydrates or fat. For example, some participants had a really rapid and prolonged increase in blood sugar and insulin, which are linked to weight gain and diabetes. Others had fat levels that peaked and lingered in the bloodstream after a meal, which is linked to developing heart disease. These differences were not due to their genes. Identical twins in their study who share all the same genes, they had really different responses. All right, so there was no interaction between the DNA and the diets when it came to these things, okay? So our diets cannot be matched to our genotype. Our responses to our diet is much more complicated than just coming down to our genes. There's other things like our gut microbiome, food combinations, sleep, exercise, all of these things play a much larger role. All right, for example, the researchers, they looked at identical twins again, and they found that these identical twins, they had different responses to the same foods. For example, in response to a sugary drink, one twin might have more than double the spike in blood sugar than the other twin. Or, if they ate a normal muffin, it might have the same thing. One twin had a spike in blood sugar, the other one didn't. But when they switched the food and switched it to a high fiber muffin, then the responses were more similar. So these researchers believe that these different responses from diet from twins might be explained by their gut microbes. Although the twins are genetically similar, their gut microbiomes are not similar. Okay, so a large majority of their gut microbiome is differing between identical twins. All right, and it also means that, just because they have the same genes doesn't mean that their genes are expressed in the same way. For example, identical twins with genes for lactose intolerance might end up with one twin being lactose intolerant and the other twin being able to enjoy all the dairy treats they like. All right, so it really, really depends on all sorts of factors. There's no evidence that we can use genes to determine which foods we should or should not eat. Now, genetics play a very minor role in determining how we respond to food. So these simple genetic tests claiming to determine the right diet for your genes, they're pretty ineffective and misleading. If you do a deep dive into the different genetic tests available for you to buy, you'll find that even between them, even in the tests from different companies, they will spit up different results. All right, they don't have an agreement on which gene means what. All right, so you can do the same test yourself. You can send your DNA to multiple different companies, and you will get different diet plans and different advice back. But for a lot of people, a lot of this personalized guidance from diet by DNA companies, it's just repackaged common sense nutritional advice that we have all heard time and time again because it works. scientists still don't know enough about this diet-gene interaction to be able to offer that type of personalized advice that would be actually helpful for dieters. So what is helpful is advice like eating your vegetables and fruits, no matter what your genotype is, right? Because this is advice that has been time proven again and again and again, and even supported by research. All right, if you want to manage a healthy weight, the best way to do that is to have a healthy diet full of all sorts of plant foods, full of all sorts of vegetables and fruits. All right, so avoid any companies that offer predictions like this. For example, I've even seen companies telling their clients that they can tell them, what sport their child will excel in, or saying, your perfect diet or other things. Using these DNA results to extrapolate that sort of information is at this point in time pseudoscience at best. So for now, just follow the nutritional advice that has been tried and tested and eat a wide variety of plant foods.
Now we will be answering some questions from the audience. If you have any questions related to health that you would like to ask Dr. EE, please leave your comment in the live chat section. Dr. EE, how does thyroid cancer happen and what are the risks of having it? What preventative measures can we take to reduce the risk of that cancer spreading? Do cancer cells metastasize faster in the brain or in any specific place in the body? Also, since cancer is a slow progressive disease, why is it still happening to children?
All right, let's tackle the first one. How does thyroid cancer happen and what are the risks of having it? What are the preventative measures we can take to reduce this risk of cancer spreading? Okay, so when it comes to thyroid cancer, a lot of the times people don't know why exactly someone gets a cancer. It's not just thyroid cancer in particular, but a lot of cancers. All right. So when it comes to cancers, for example, if you have a smoker who comes down with lung cancer, doctors might say, it's probably due to the smoking, but it's impossible to say, 100% is due to the smoking. It's probably due to the smoking, but they can't say that they're 100% sure because you can't know. There's a lot of things that you could be exposed to throughout all of the years that you're living. And a lot of these carcinogens, they might take time to develop cancer. All right, so it's really, really hard for doctors to pinpoint and say exactly why a cancer happens, but there's a lot of things that can increase the risks of cancer. For example, thyroid cancer is one of those things that a lot of the times will just happen and people don't know why exactly. But another thing that will put people at risk of thyroid disease in particular is things like radiation. That's why, if you ever look at the techs controlling those x-ray equipments, they always wear those lead jackets and they always wear a collar as well. If they don't wear a collar, they really should be wearing a collar here around their neck, a lead collar here, and that's to protect their thyroid. Okay, if they're not doing that, they really should be doing that. And even if you're going for x-rays for yourself, if they're not x-raying this bit of their body, you can still wear a collar there to protect your thyroid from radiation, because that is one of those things that will increase your risk. In fact, the people who work together with x-rays and all of these equipment, they actually have a higher risk of a lot of cancers. And one of those cancers is thyroid cancer because of their exposure to things like radiation. Right? And what are the risks of having thyroid cancer? Now, if you have a thyroid cancer, it's much like cancer in any other area of the body. The cancer there will not function properly, and it also depends on exactly what type of cancer you get. All right, so thyroid cancer is not just one type of cancer. It's always split into, what tissue is cancerous, what appearance does the cancer have, what subtype of cancer is it, because there are some subtypes of cancer which will release chemicals into your body, whether they be hormones or other transmitters that can wreak havoc on your body. Right, but one thing that will happen is that the thyroid cancer will affect your thyroid function, either pushing it up or suppressing it down. Right? And for some types of thyroid cancer, some rare types of thyroid cancer are incredibly aggressive. and they will grow quickly and they will metastasize quickly. So when it comes to trying to stop cancer cells from metastasizing or spreading, a lot of it depends on, number one, the type of cancer you have. If you have a slow growing cancer, then it might be that these cancer cells will metastasize or spread slower. And it's also other things as well. For example, if you have a really aggressive type of cancer, then you might just be really unlucky and have the type of cancer that can spread really, really quickly. All right, and it's also other things as well. For example, if you have other diseases in place, or if you compromise the boundary function of a lot of things. For example, one of the risks of doctors taking biopsies from cancer cells is that if they don't do it properly, they risk spreading the cancer because they're sticking something into the cancer and they're also opening up that pathway for cancer cells to spread. But in most cases, this doesn't happen, so don't be concerned, okay? But it is a risk for cancer cells metastasizing faster or slower. A lot of the times it depends on the type of cancer you have, and also it depends a lot on your comorbidities as well. Is your body, fighting against the cancer, or are you super weak and your cancer is just basically taking advantage of your body as it wishes? Okay, so when it comes to cancer cells metastasizing faster in the brain or other specific places, again, it really depends on the type of cancer you have. Some cancers will very rarely metastasize. For example, prostate cancer is one of those cancers which very, very rarely metastasizes. In fact, people are more likely to die with prostate cancer, meaning that they die of other things like heart disease, than to die of prostate cancer itself, whereas other cancers will metastasize super quickly. For example, skin cancer, melanoma, is one of those cancers where, by the time you notice you have an abnormal mole and go to the dermatologist to check it out, it might have already metastasized. All right, so it really depends on the type of cancer that you have. And when it comes to children, yes, cancer is a slow progressive disease, but not all cancers are slow and progressive. And oftentimes, children who have cancer, their cancer is not the type that occurs because of an unhealthy lifestyle, because they haven't had that time to damage their body cells with a poor diet and a poor lifestyle. Unfortunately, they haven't had that time yet to build up that level of damage. So a lot of the time, what happens to children who have cancer is that for children who have cancer, oftentimes it is a genetic component that is pushing their cancer to occur. Some children can unluckily be even born with tumors. All right, so for children with cancer, they have a genetic they often have a genetic component to their cancer, and because of this, they were born with the cancer. They already have the cancer, and for some of them, it can be one of those cancers that can spread and progress much faster.
Dr. EE, can cancer reoccur after treatments when doctors claim that a person is cancer-free? Also, is it possible that a benign cyst will mutate or become cancerous later? Also, when a cancer patient goes through cancer treatment and the CT scan shows no cancer cells are detected, does that mean that all the cancer cells were destroyed?
All right, so I'm going to link the first and the last one together. Can cancer reoccur after treatments when the doctors claim that you are cancer-free? So there's a reason why doctors will never say that they can cure cancer, because a lot of the times you're not curing cancer because you don't know. You can't know if you have gotten every single cancer cell in the body. Even if you've had a CT scan scanning your body and they can't find any tumors, all that means is that they can't find any tumors, okay? It doesn't mean that they can't find any cancer cells. It means that they haven't found any tumors. And like I mentioned before, for a CT scan, the threshold for finding a tumor is about 4 to 6 millimeters. So all that means is that they can't find any tumors of that size or bigger. All right, you could have a single cancer cell hiding somewhere in the body, and none of our scans currently will be able to find it. You can have just one cancer cell, and all you need is that one cancer cell for that one cancer cell to slowly divide and spread and propagate again to form a tumor. So it's no guarantee that you will never have a reoccurrence, that you will never end up with cancer later on in life. Okay, there is no guarantee, unfortunately. All they can say is that they can't find anymore, and that is a good sign. Okay, that is a good sign. So it's not something bad, and that is something that we want to aim towards, because we want to aim towards for the best that we can manage at the moment. All right, so it's all about, killing all of the cancer cells that you can, and hoping that your immune cells and your body will pick up the rest that we can't find, pick up the rest that the chemotherapy or the radiation therapy couldn't manage to kill. We hope that your body will be able to control the cancer because we have gotten rid of the majority of the cancer cells for you. So it's not just relying entirely on the doctor and on the scans and on the chemotherapy and the radiation therapy, okay? We don't want to rely 100% on them, because as you know, the chemotherapy and the radiation therapy, these are very toxic treatments. You need to go through it in order to get rid of the cancer cells, but that doesn't mean that the chemotherapy and the radiation therapy doesn't harm your body. It will. All right, people who go through these treatments will have an increased risk of getting cancer later on in their life, not a recurrence of their previous cancer, but the onset of a new previous cancer that they never had previously had before. Okay, so these treatments itself will put you at an increased risk of getting a new type of cancer later. And there is no crystal ball that will tell you exactly if you will or will not get cancer. So we have to work together. We have to work together with the doctors and their treatments, but we also have to do our own part. We can't just say, oh, the doctor will do their things and that's all I'm going to do. We also have to do our own part of keeping our body healthy, of eating healthy, of cutting down on these unhealthy lifestyle habits. We have to do this part as well to help support our body, to help support our immune system, so that our immune system can work together with the treatments from the doctor to eliminate these cancer cells. Now, is it possible that a benign cyst will mutate or become cancerous in later days? It is possible, but depending on the type of cyst, it's very, very unlikely. Okay, so for example, a lot of people might be worried that, a cyst on their kidney or on their ovary might become cancerous later on in life. All right, we can't say that 100% it will never become cancerous, because we don't have a crystal ball that will say 100%. But we can say that for the majority of these benign cysts, it is very, very unlikely. Okay, so if you have a cyst like this, what goes on is that, depending on where it is, you might just want to leave it for observation. For example, a lot of cysts on the ovaries, doctors will just leave them as they are, because the risk of going through surgery to remove it is just not worth the harm of just leaving the cyst in place. They might remove the cyst if it gets really, really big, because it might start compressing on the other organs around it. If it shows precancerous signs within the cyst, but if it did, then they might just remove it for the risk of becoming cancer. But if they don't see any of those abnormal signs there, it's not very large, it's not pressing on anything, it's not causing you any pain, you're not getting any bleeding inside the cyst, etc., they might just leave it in place and just leave it for observation and keep an eye on it. All right, so for the vast majority of cases, benign cyst is super unlikely for it to turn cancerous. All right, but we can't say 100% that it will not.
Dr. Yi, can you tell us about the developments of vaccines to fight the ever-mutating COVID-19 virus? Also, can you share more about ivermectin, as many people are using this medication for COVID-19 treatment? And does ivermectin help COVID-19 patients recover?
So if you look at these developments for the new technology to develop COVID-19 vaccines, a lot of people are really concerned, because they say, oh, it's a new technology. The virus or that vaccine happened too quickly? What if they skip some steps up there? What if it means that this vaccine is not as safe as the other older technologies of the vaccines? So when it comes to these concerns, when it comes to this mRNA technology to develop vaccines, it's actually not a new technology. It just seems like a new technology because it only came into the news recently. It's actually been in development since SARS. All right, so well, if you look at the grand scheme of things, some people would say that this is a new technology, but it's been in development for years and years and years now. So it's not really anything new, as in it happened only since COVID-19. This technology has been around for a while. Okay, so it's not something that is super new. It is an established technology that has been used now to make a vaccine for COVID-19. All right, so this mRNA vaccine is actually super useful, especially for COVID-19, because what happens is that with the mRNA vaccine, the development or the production of the vaccine is much faster. They can manufacture it a lot faster than other vaccines. For example, the live attenuated vaccines or the inactivated vaccines. The production speed of an mRNA vaccine is much faster, meaning that we can reach more people in a shorter amount of time. But also when it comes to COVID-19, since we're having all sorts of variants pop up around the world, what happens with an mRNA vaccine is that it's more simple for them to adjust this vaccine to cover the variants in the future if they choose to do that, rather than trying to develop a new inactivated or other types of vaccines from the very beginning. They have this technology, all they have to do is edit it so that this mRNA sequence will code for a different protein on the new variants of the virus to put in the vaccine. Okay, so far for the mRNA vaccine, it is a pretty safe technology. All right, it's not going to change your genes. You don't have to worry about that. Doesn't have that capability to do that. All right, so you don't have to worry about it being a super new technology. Yes, it's a new vaccine, but the technology behind it is not new. Okay, so it is a very exciting period of time because now that mRNA vaccines have been pushed out for COVID-19, a lot of researchers are looking at this technology to come up with vaccines for all sorts of other diseases as well. So hopefully, maybe in the future, we'll end up with vaccines for diseases that were previously unable to be vaccinated against, which is something that is really exciting. So I'm excited for the future of mRNA and for the future of different types of mRNA vaccines. All right, so if you look at this, things like inflammasome. Now, inflammasome is another thing that people have been looking towards or ivermectin is something that people have been looking for treating COVID-19. All right, so what is this drug? All right, it is something that's completely useless for COVID-19. So researchers have actually done trials for this drug and they found that it is completely useless for treating COVID-19. It is not something that you should be using for COVID-19. You shouldn't inject it. You shouldn't use any tablets for it, okay? So far, it is not one of the approved treatments for COVID-19 because you will be wasting your time. When it comes to treating COVID-19, there are a few treatments that they might recommend. For example, for someone who is in the hospital with COVID-19, they might recommend a course of steroids to help prevent that sort of cytokine storm that might be flaring up. They might recommend, other measures as well, such as high flow oxygen or turning the patients around to try to get their lungs to be able to absorb oxygen a little bit better. But this drug is not one of them, okay? When it comes to COVID-19, again, it's the same principle. We don't want to wait or put ourselves at risk of getting disease and then trying to cure it after the fact. We want to work on trying to prevent ourselves from getting COVID-19 to begin with. And that is one of the things that we can work on doing. We have to socially distance, keep our hands clean, wear our mask, and please, if you are able to, get the vaccine. right? One of the many reasons why we see so many of these variants popping up is because there are not enough people vaccinated. Vaccines are one of the tools that we do have to help combat viruses mutating and, popping up with these new variants. Okay, there's a lot of things that we can't do to stop that because that's just how that's just how viruses work. But one of the things that we can do to help stop this mutation is to get vaccinated, because viruses mutate. The more they are allowed to spread and replicate, the more they will mutate. So if we have a large pool of people who will be infected with COVID-19 and then allow this virus to replicate within their body, then the more likely that we will end up with more and more variants. So if we have a large population of vaccinated people who will not allow COVID-19 to replicate in their body, who will not come down with COVID-19, then we will hopefully be able to cut down on all of these variants that are popping up. For a lot of people as well, when it comes to getting the vaccine, a lot of people might think, oh, what about all of these variants and these breakthrough cases? Does this mean that there's no point in getting the vaccine anymore? Yes, these variants, they do break through the vaccine more often than I guess I can call it the normal strain of COVID-19. Oh gosh. So when it comes to this, it's still important to get the vaccine, because what the vaccine also does is that it helps prevent severe disease. So even if you get COVID-19, with the vaccine will give you protection against severe disease. So you will more likely not end up in hospital taking away an ICU bed from someone who needs it more. For example, someone with heart disease, or someone with cancer, or someone with lung disease that needs the ICU bed. All right, so when it comes to this, it's all about doing our part to help control this pandemic together.
Dr. EE, does high blood pressure medication absorb the salt inside our bodies, causing low sodium levels? And if not, what causes these low sodium levels?
So high blood pressure medication, there's a lot of different classes of high blood pressure medication. One of the classes of high blood pressure medication is actually causing your heart rate to be a little bit slower. So it's a controlled heart rate. So another type of blood pressure medication will dilate your blood vessels. So the wider your blood vessels, the lower the pressure. And another type of blood pressure medication, which will bring down your sodium levels, is something called a diuretic. And what this type of medication does is that it makes you pee more. And because you pee more, you're getting rid of excess water in your body, which will bring down the blood pressure. But because you are going to the toilet so often and getting rid of so much water, how our body works is that it will also get rid of sodium as well in order to get rid of this water. So people who are going to the toilet way too much might be excreting too much sodium along with the water content of their bodies, okay? So that's one of the things that can help bring down the sodium levels in your body. Another thing that will bring down sodium levels in your body are certain medications, not including heart pressure medications, but also other medications. For example, there are some other types of diuretics that might be used for other diseases as well, or for actually the most common cause of low sodium is what is called idiopathic hyponatremia, which means that oftentimes people will very often see low sodium levels, especially in the elderly population, and doctors don't quite know why exactly the sodium is that low. But another reason why sodium can be super low is due to other diseases as well. All right, so there's a lot of diseases that can bring sodium levels down low, and also a lot of the times it's also just due to the person. I remember one person we had on our ward that had super low sodium levels because he would not stop drinking water. So if you drink way too much water, and it takes a lot, you will drive down your sodium levels. So for a lot of the times, if you have sodium levels that are too low, a lot of the treatment is just cutting down on the water intake. Stop drinking so much water, because if you drink too much water, it actually dilutes the electrolytes inside your blood because, well, it's just like if you have a cup of water and you dissolve some salt in it, right? If you have a little bit of water, it tastes really salty. If you add in more water, it gets less salty, right? Same concept with your body. All right, so a lot of the times when it comes to low sodium in the body, we have to figure out what causes it. If it's medications, we can try changing the medications. If it's a disease, we can try treating the disease. If someone has low sodium because they're drinking too much water, then the solution there is to cut down on the amount of water that they're drinking.
Dr. E, is mold on onions harmful? It's very common on yellow onions.
So if you have mold on onions, if you have mold on any sort of food, I would strongly recommend that you do not eat it. All right. There are some foods that will have mold growing on it. For example, some cheeses will have mold growing on it. Some types of tofu will have mold growing on it. All right. That is a different type of mold because that is a specially cultivated mold grown in specially controlled environments. Okay, that type of mold is it's I mean, like, it's not healthy, but it's not going to cause the same amount of harm like the aflatoxin will. So if you have mold on your food, I would really, really, really recommend to do not eat the food because the portion of the mold that we can see is actually their reproductive system of the mold. All right, so the vast majority of the mold, the tendrils of the mold, is actually already spreading throughout the food. Okay, so if you have mold, visible mold on a food, the mold has already grown to the point where it's ready to, reproduce and spread to other areas. So it's already a well-established mold and you really should avoid eating it.
Dr. E, I understand the only available treatments for cancer right now are radiation and chemotherapy. Is it safe to undergo these treatments?
So right now, there's a lot of different types of treatments for cancer, not only radiation and chemotherapy. There are often other types of newer therapies as well. For example, targeted therapy or immunotherapy. But those therapies are only available for certain very specific types of cancer. So it's not available for every cancer on Earth. Whereas chemotherapy and radiation therapy are one of those therapies that is more universal. All right, so radiation therapy works by, killing the cancer cells via radiation. Chemotherapy is a drug that will often target fast-growing cells, and that's why it will target cancer cells because cancer cells, they're greedy cells. They will suck up all of the nutrients and they tend to suck up all of the chemotherapy as well, which is toxic to them, and so they will die off. But that's also why people on chemotherapy, they will lose their hair because hair is fast-growing. They will get mouth ulcers because the lining of our mouth is those cells that will quickly replenish as well. All right, so yes, these therapies are not safe. All right, but it's a balance of would you rather get radiation or chemotherapy or die of cancer? It's a balance of those things. So when it comes to medicine, it's never, we're going to give you this and it's never going to have any risk. It's only going to have benefits. It's never that way. All right, when it comes to medicine, it's always a balance of risk via benefit. All right, and if the benefit outweighs risks, then you're going to go for it. And when it comes to radiation and chemotherapy, the benefit is a chance to survive cancer. So you're going to go for it, right? So because normally these therapies are really harmful to the body. Okay, you will have all sorts of side effects. People can end up with radiation burns from radiation therapy, though our technology now is getting much better, so that's less likely to happen. But still, chemotherapy is also really toxic to the body. It is pretty terrible for a lot of the people going through it. They are pretty miserable a lot of the time. They will feel nauseous. You will vomit. You will feel tired. You can go through a lot of different pains. You lose your hair. You get mouth ulcers. You can't eat. It's pretty terrible experience. So no, they're not safe, but they're preferable to the alternative.
Dr. E, during chemo and targeted treatment for breast cancer, can you tell us what nutrition we can take that will not interact or affect the effectiveness of the chemo treatment? Also, is it true that we should not consume fruit and vegetable juice after chemotherapy?
So there's been some articles on the internet going, oh, this and this so-called expert has said you can't have certain foods during chemotherapy because it will interfere with the chemotherapy process. All right, so in my opinion, when you have a disease like cancer, if you have any disease actually, and it doesn't matter what sort of treatment you're going through, I feel like the role of a doctor is always to encourage your patients to have a healthy lifestyle. So when it comes to a healthy lifestyle, a part of that is a healthy diet. And when it comes to a healthy diet, a lot of healthy foods will contain things like antioxidants. Right? And some of these so-called experts will say you can't have these foods because the antioxidants will interfere with the chemo and neutralize the chemotherapy, because antioxidants and chemotherapy will help kill these cancer cells because it's toxic, right? Cancer cells will absorb it and then they die off. But they fear that the antioxidants from healthy food will interfere with the chemo before it can get to the cancer cells. So all of this is just it's more theoretical than anything else. No one has done a test showing that, oh, we can show definitively that you can't have blueberries or something with chemotherapy because it renders the chemotherapy useless. There is no robust scientific research showing that sort of evidence. All right. So all of this is very much a thought experiment. It's very much, oh, theoretically, we think it might do this, therefore we will warn against it. But I feel like when it comes to all of these diseases, all of this cancer, or even heart disease, or even if you're on chemo, what's really important for a doctor is to not only educate their patients about a healthy lifestyle, but also to encourage a healthy lifestyle. Because a lot of the times patients will come down with diseases because they don't know any better. Right? They never learned about the ways of healthy eating in school. They never learned about, what exactly might increase the risk of a disease. They just don't know. All right. So as part of a doctor, I feel like it's also part of our jobs to help support our patients in this way, because it's not enough to only focus on treating the disease. Because if you're only regulating it, just like regulating yourself to that one area, then what happens is that the patient will never learn. They will never learn what they can do to keep themselves healthy. They will never learn what they can do to prevent the disease to begin with. So what happens then is that they will keep coming in with disease again and again and again. I see a lot with heart patients. They will come in for a stenting, right? And then a few years later, they come in for a coronary bypass surgery because they don't know any better. They just don't change their lifestyle to prevent this to begin with. So if you have cancer, even if you're undergoing chemotherapy, I would recommend everyone to eat a healthy diet full of all sorts of plant foods. Okay? And for people who are on chemotherapy, you're often pretty miserable. You often don't have very much appetite as well. All right, so if all you can have is fruit juice or vegetable juice, you can't stomach the actual fruit or vegetable, you know what? That's fine too. I will take anything that I can get. Okay, but we also have to remember, on the flip side, we also want to take care of our mental health as well, because when it comes to chemotherapy and cancer, it's tough. It's really tough on people, physically and mentally. All right, so if you are on chemotherapy, if you have cancer, yes, you do want to eat healthy most of the time, but if you have a terrible day, okay, you can have a scoop of ice cream if you can stomach it. You can have a milkshake. You can have a bite of cake. Okay, if it will make your day better, then go ahead and do it. All right, when it comes to our healthy living, it's not just about eating healthy. We also want to take care of our entire selves, and that means our physical and our mental health. So all I ask for is that you eat healthy most of the time. You don't have to do it 100% of the time, because I know that's unrealistic. But if you can manage to do it most of the time, if you can manage to make these small changes to your lifestyle and keep up with it, that's already really fantastic.
Due to time constraints, the next question will be our last question. Dr. EE, Some people turn pale after drinking. Is this a symptom of the kidney's function in removing alcohol from our body?
So, when it comes to alcohol, a lot of people will have different effects to alcohol. The one we're worried about is flushing red after drinking. But a lot of people, people who drink, some people will be angry. Some people are really happy. Some people are really silly, right? But some people will get nauseous as well. So it depends on the level of alcohol you drink. If you drink a lot and lot of alcohol, you can start having other effects on your body. So will start to have an effect on your higher brain functions. It can make you feel slightly ill as well. And a lot of people who are feeling unwell or when their body isn't in the tip top shape, they often have that sort of waxy complexion. So you don't actually, it doesn't necessarily mean that, something is super wrong with you beyond the alcohol drinking. And so it is not something to be super concerned about, not like the flushing red when you drink. If you flush red when you drink, we should really avoid alcohol entirely. I should also add that the kidneys don't break down alcohol, it's the liver that breaks down your alcohol. All right. And you also have to remember is that alcohol is a toxin. All right. It is harmful to the body. So if you drink, what you are doing is that you are causing harm to the body, and people will react to this harm in different ways. Some people will feel really nauseous. Some people just feel really dizzy. Some people just feel not quite right. And as I've mentioned before, our inner health is often reflected on the outside. So our skin reflects our inner health. Our complexion reflects our inner health. That's why people who are sick, who are unwell, you can tell just by looking at them. In fact, what they teach us in medical school is that your very first thing when assessing a patient is to just stand at the foot of the bed and take a look at them and take a look at how they're looking in the bed. Do they look well? How is their complexion? Do they look very ill? Like just take in all of the things at once to form a general idea of how they're doing. But this can apply to anyone. All right, so there is no particular reason why some people might turn pale after drinking, but it might just be a reflection that they're drinking alcohol and that alcohol is a toxin. So please, try to avoid drinking alcohol.
Thank you, Dr. EE, for taking your time to educate us regarding health today.
Thank you so much. I'm so grateful to have this opportunity to share all of this knowledge with you. I hope it was both entertaining and informative.
Thank you, everyone, for watching. This video will be accessible until August 18th, 9 a.m. Take care and stay safe. Goodbye.